When scientists saw the pictures, they were shocked. The far side looked completely different than the near side. It's saturated with craters. It just was such a huge dichotomy. Nobody was expecting that at all.
After traveling more than 1 million miles from Earth and spending months getting ready to collect data from the outer regions of space, the James Webb Space Telescope JWST project has already begun transmitting full-color photographs to NASA. This project promised to take the most detailed and sharpest infrared photographs there have ever been of distant galaxies. These photographs would help solve puzzles regarding the beginnings of the universe. Through the use of the telescope, we are able to observe galaxies and stars in the same state that they were in 13 billion years ago. This enables us to peer further into space than ever before. Ever since that time, the revolutionary projects that NASA has been working on have consistently provided a steady stream of spectacular photographs. The James Webb Space Telescope produced photographs that are mind-blowing in terms of their sharpness and level of detail. What new knowledge and data do we have from the James Webb and the Hubble Space Telescope? Let's find out. Of course, the James Webb isn't only there to blow our minds, according to specialists from NASA. Its work will be vital for having a better understanding of the universe as it is right now, as well as its early past. Another successful mission has been accomplished by the James Webb Space Telescope, which is already well known for the stunning photos it has taken of the universe. Having captured its first image of Neptune, the James Webb Space Telescope from NASA has demonstrated its capabilities in a more concrete manner. The cameras on the Webb Space Telescope not only gave the best view of the planet's rings in more than 3 decades, but they also revealed fresh information about the ice giants with their findings. The purity of the planet's rings, some of which have not been seen since the Voyager 2 spacecraft from NASA became the first spacecraft to explore Neptune during its approach in 1989, is what sticks out the most in the most recent snapshot taken by Webb. In addition to a great number of dazzling narrow rings, the Webb image brings to life the fainter dust bands that are associated with Neptune. It has been 30 years since the last time we saw, as stated by Heidi Hamel, who is a transdisciplinary scientist at Webb and an expert in the Neptune system. We have never before observed these faint dusty rings in the infrared spectrum. This is the first time we have seen them. These extremely feeble rings were found so close to Neptune as a result of the exceptionally consistent and exact image quality that Webb maintained throughout its mission. Researchers have been attracted by Neptune ever since it was discovered in the year 1846. When compared to Earth, Neptune is 30 times farther away from the Sun than Earth is. It circles in the farthest, darkest part of the outer solar system. Due to the fact that the Sun seems to be so little and faint when viewed from such a big distance away, high noon on Neptune is akin to adult twilight on Earth. As a result of the composition of its internal chemical makeup, this planet is classified as an ice giant. Neptune is far more abundant in elements that are heavier than hydrogen and helium than Jupiter and Saturn, which are also considered to be gas giants. Neptune is able to appear distinctly blue in photographs taken by the Hubble Space Telescope at visible wavelengths because of the presence of small amounts of gaseous methane. This is something that may be easily observed. Due to the fact that his near-infrared camera NIRCam can only detect objects in the near-infrared band between 0.6 and 5 microns, Neptune does not appear blue to Webb. In point of fact, as a result of the significant absorption of red and infrared light by methane gas, the planet seems to be relatively dark at these near-infrared wavelengths. The only exception to this is regions that are covered by clouds at high altitudes. Because they reflect sunlight before it is absorbed by methane gas, these bright streaks and spots of methane ice clouds are apparent. Methane gas is released into the atmosphere. Images taken by other observatories, including as the Hubble Space Telescope and the Dogyeom Keck Observatory, have been able to capture these fast-shifting cloud characteristics over the course of several years. It is possible that a thin line of brightness that circles the equator of the planet could serve as a more discrete visual indicator of the global atmospheric circulation that is responsible for the winds and storms that are associated with Neptune. It is in the equator that the atmosphere begins to decrease and warm, causing it to have lighter infrared wavelengths than the gases that are located nearby that are cooler. As a result of its 164-year orbit, the northern pole of Neptune, which is located toward the top of this image, is only barely visible to astronomers. However, the Webb photographs show that it has an unusually dazzling appearance. The image captured by there's Webb clearly demonstrates a vortex that has been observed around the southern pole in the past. Nevertheless, this is the first time that Webb has demonstrated a continuous band of high-latitude clouds surrounding the vortex. A highly dazzling point of lights with the unique diffraction spikes visible in many of Webb's images dominates this Webb painting of Neptune. Webb was also responsible for the discovery of 7 of the 14 moons that are known to orbit around Neptune. Nevertheless, this object is not a star. Rather, it is a star. Triton, the large and peculiar moon of Neptune, is fortunate enough to have a frozen coating of condensed nitrogen covering it, which allows it to reflect almost 70% of the sunlight that it receives. Due to the fact that methane absorbs light at these near-infrared wavelengths, it achieves a significantly higher level of brightness than Neptune in this photograph. As a result of Triton's odd retrograde orbit around Neptune, astronomers have come up with the hypothesis that this moon was previously a Kuiper belt object that was gravitationally captured by Neptune. In addition, the James Webb Space Telescope has successfully captured its first images of Mars by carefully analyzing infrared light that originates from the planet. During the Europlanet Science Congress EPSC 2022, which took place on September 19th, the first photographs and spectra of Mars taken by the James Webb Space Telescope were made available to the general public. The images and measurements were taken by the James Webb Space Telescope, JWST, on September 5th, 2022, the day that it was around 1 million miles, 1.6 million kilometers, away from Mars. The near-infrared camera NIRCam on the Webb Space Telescope was responsible for capturing the photographs of the viewable disk on Mars, which is the side of the planet that is facing the observatory and is lighted by the sun. In addition to providing data that can be utilized in concert with observations performed by rovers such as NASA's Perseverance and objects in the Martian orbit, they could provide planetary scientists with a unique perspective of the planet that is located in close proximity to Earth. Considering that Mars is somewhat close and has a high level of brightness, it is not the easiest object for the James Webb Space Telescope, JWST, which is meant to observe things that are exceedingly far away and dark. Due to the fact that the JWST is able to capture images and spectra with the spatial resolution that is necessary for them, astronomers are able to study short-term phenomena such as Martian weather patterns, dust storms, and even changes brought about by the planet's seasons. Additionally, the Webb Telescope enables simultaneous observation of events that occur throughout the day on Mars, including during the day, during sunset, and during the night. 2 distinct wavelengths of light are used to illustrate the eastern hemisphere of Mars in the first photographs taken by the James Webb Space Telescope. The short wavelength image, which displays elements of the Martian terrain that are similar to those seen in visible lights, is dominated by the reflected sunshine that they have. A few examples of these features are the dark volcanic rock that makes up the Circus Main Plem and the hydrogen crater, which is nearly 280 miles wide and equivalent to 450 kilometers in diameter. The near camera on the Webb Satellite Telescope was able to record the lights that Mars emits at longer infrared wavelengths as it goes through the process of losing heat. There is a correlation between the temperature of Mars and its atmosphere and the brightest and warmest part of this light, which is visible where the sun is virtually directly overhead the planet. There is a drop in brightness in the northern hemisphere of the planet, which is currently experiencing Martian winter, as well as in the polar areas of Mars, which receive less sunlight. On the other hand, the amount of light that has the ability to reach the JWST is not completely dependent on the temperature of the planet. The chemical composition of the Martian atmosphere and surface can also be inferred from the photographs taken by the telescope. Astronomers may be able to gain additional knowledge about Mars's atmosphere and surface by analyzing the spectrum of light that was detected emanating from the planet using data obtained from the James Webb Space Telescope. An examination of the photographs taken by the James Webb Space Telescope reveals that during the hottest portion of the day on Mars, the 1,200-mile or 1,930-kilometer Heller space appearance seems darker than its surrounds. By entering the atmosphere of Mars and being absorbed by carbon dioxide, the impact structures appear to have darkened. This is the result of the lights entering the environment. The new photos also demonstrate how the James Webb Space Telescope may examine Mars by employing a technique known as spectroscopy, which involves taking measurements with the telescope's near-infrared spectrograph near-spec equipment. As a result of the fact that chemical elements absorb and emit light at very specific wavelengths, spectroscopy can be utilized by planetary scientists in order to determine the composition of a planet by analyzing the fingerprints that various chemicals leave behind in the light that is emanating from the atmosphere of the planet. Spectral patterns that are encoded with information about Martian dust-frozen clouds, which are all components of the atmosphere, as well as the types of minerals that may be found on the surface of the planet, are revealed by the early discoveries made by the scientists. Observations with the James Webb Space Telescope, JWST, ought to be able to identify water, carbon dioxide, carbon monoxide, and other chemical components. Methane is important because it can provide information to planetary scientists about a range of geological processes that are taking place on Mars. A few examples of these processes include determining whether or not a major object has recently struck the red planet from orbit. There is also the possibility that methane can reveal proof of previous biological activity on the planets. The Webb Telescope has also captured the first definite trace of carbon dioxide in the atmosphere of an extrasolar planet. This was a significant discovery. The discovery not only offers intriguing clues as to how the exoplanet developed, but it also serves as a preview of what to expect when Webb investigates more and more extraterrestrial planets. The discoveries shown in a data plot that lacks the brilliance of Webb's earlier photos, which featured galaxies' courts in a cosmic dance and dazzling clouds in a star nursery. However, according to Jess Christensen, an astronomer at the NASA Planetary Science Institute at the California Institute of Technology in Pasadena, the results are stunning. The exoplanet WASP 39b is referred to as a hot Jupiter by scientists due to the fact that it has a diameter that is comparable to that of Jupiter. However, it orbits its star that is somewhat closer to the Sun than Mercury does, which causes it to be exceedingly hot. The plot, also known as the spectrum, offers specific information regarding the atmospheres of the extrasolar planets as well. The planet, which is located more than 200 parsecs distant from Earth, was discovered for the first time in 2003 through research conducted on the terrestrial base. The Spitzer Space Telescope, which was in operation from 2003 to 2020, was the scientific instrument that ultimately discovered it. Despite the fact that the latter's data were inconclusive, they did raise the possibility that the atmosphere of WASP 39b includes carbon dioxide. Following that, Webb came into play. On July 10, the infrared telescope followed the planet as it traveled across the surface of its star for a little more than 8 hours. During this time period, sunlight was able to pass through the atmosphere of the planet and was absorbed by various molecules at certain wavelengths of infrared light. In the scientific community, there was a question regarding whether or not carbon dioxide would appear as a visible blip in the spectrum. Natali Patala, an astronomer at the University of California, Santa Cruz, UCSC, is the leader of the team that is responsible for the early release science of Webb's Transiting Exoplanet program. According to her, the results have increased her conviction that the Webb Space Telescope will be a game changer for the field of exoplanet study. And there it was, just springing off the computer screen. In the first year of operation, the telescope is to observe 76 extrasolar planets, as per the instructions given to it. It is possible that the total will reach hundreds during the length of its existence. During this period, it will observe its way through the atmospheres of small rocky worlds that could be similar to Earth and gas giants. Despite the fact that the discovery of carbon dioxide is remarkable in and of itself, it is reasonable to predict that a planet like Jupiter, which originated from the same disk of matter as its star, would have the same chemical composition as the star. A significant carbon dioxide signal from the exoplanet indicates that it is laden with components that are heavier than the hydrogen and helium that ordinarily make up stars. However, this is not the case for either the exoplanet known as WASP-39b or for our own solar system. Why does the matter at hand exist? After that, the narrative starts to gather up steam. It is likely that comets and asteroids struck WASP-39b when it was still young, delivering heavier components such as carbon and oxygen. The fact that the exoplanet appears to possess the same quantity of heavy elements as Saturn, which astronomers believe also had a stormy youth, is an interesting fact to take into consideration. On the other hand, it is plausible that WASP-39b developed from materials that were located in the frigid outer boundaries of its planetary system before advancing within. When it arrived at its final resting place, it was in close proximity to its host star, which may have caused a portion of the hydrogen in the atmosphere of the exoplanet to be blasted away, thereby concentrating the heavier elements and enriching them with carbon dioxide. Scientists are currently working on 4 articles that will investigate these possibilities and conduct a much more in-depth analysis of the spectrum of the planet. The discovery of carbon dioxide in the atmosphere of a planet is the first stage in this process. Astronomers believe that the star WASP-39b is too close to its star for it to be able to support life, and they also do not predict that it will be able to maintain life. They do not even make the assumption that the Webb Telescope will uncover proof that cannot be refuted of the existence of extraterrestrial life. Astronomers believe that the presence of carbon dioxide and methane in the atmosphere of a planet is evidence of the presence of life. In the end, the discovery of life will most likely require an observatory that is significantly more advanced than the Internet. However, in order for us to be ready for the technology that will be available in the future, we need to get through this extremely important point in time. On the other hand, the Hubble Space Telescope has made a significant advancement in its quest to determine the rate at which the universe is expanding, which is consistent with the notion that something weird is going on in the cosmos. Astronomers have recently utilized telescopes like Hubble to precisely measure how quickly the cosmos is expanding. But as those measurements have improved in accuracy, they have also revealed an oddity when compared to observations made just after the Big Bang. There is a significant difference in the rates of the universe's expansion as it is now. This mismatch is beyond the knowledge of scientists, but it suggests that something peculiar is taking place in our universe, which may be the result of brand new physics that has not yet been found. The Hubble Space Telescope has been collecting data on a collection of milepost markers in space and time for the past 30 years. This data can be used to measure the rate at which the universe is expanding as it moves further and further away from Earth. In accordance with NASA, the organization has successfully calibrated over 40 of the markers, which enables even greater precision. You are obtaining the most exact measure of the expansion rate of the universe from the gold standard of telescopes and cosmic mile markers, according to a statement released by Adam Rees, who was awarded the Nobel Prize and works at the Space Telescope Science Institute, STSCI, and Johns Hopkins University in Baltimore, Maryland. The search for an accurate estimate of how quickly space was expanding began when the American astronomer Edwin Hubble noticed that galaxies that were not our own appeared to be moving away from us, and doing so at a faster rate the further away they were from us. Since that time, researchers have been doing their best to find a more satisfactory explanation for that growth. We would like to thank you for viewing another episode of Beyond Earth. While you are still here, make sure to click the video on your screen to view further mind-blowing videos about space. This is a time when incredible discoveries are being made, and we are here to keep you updated on all of them.